Welcome to this lesson. Today we are going to look at Form 3 Chemistry under the mole, but in this case we are going to look at a question where we are supposed to determine the molecular formula. And the question reads, an organic compound contains carbon and hydrogen only. When this compound was burnt in excess air, it gave 9.6 grams of carbon dioxide and 4.9 grams of water. The molecular mass of the hydrocarbon is 58. Determine the molecular formula. So let us look at the solution to this question. An organic compound that contains carbon and hydrogen only, we call it a hydrocarbon. But when this hydrocarbon was burnt in excess air, it gave out 9.6 grams of carbon dioxide. So one thing that we are supposed to do is to calculate first the mass of carbon from carbon dioxide. We know carbon has a relative atomic mass of 12 divided by the molecular mass of carbon dioxide, which is 44. We multiply by the mass that was produced of 9.6, and this one gives us 2.618 to 3 decimal places. From there we can now calculate the mass of hydrogen from water, and the mass of hydrogen is going to be 2. You divide by the molecular mass of water, which is 18. We multiply by the mass that was produced of 4.9, and this one will give us a mass of 0.544, correct to 3 decimal places. Having gotten the mass of carbon and that of hydrogen, we can now move down and calculate the empirical formula. To calculate the empirical formula, we have to identify the elements present in that compound. And the elements present in this compound, since it's a hydrocarbon, we have carbon and hydrogen. Once we have the elements present, we go to the next step where we look at their mass and their masses. The mass of carbon is 2.618 and that of hydrogen is 0.544. Once we have the mass, we can now look at the relative atomic mass, and the relative atomic mass of carbon is usually 12, that of hydrogen is 1. And once we have the mass and the RAM, we can calculate the moles, and we know for us to get the moles, we take the mass, we divide by the RAM. So if you take 2.618, you divide by 12, this one will be equal to 0.2182, and if you take 0.544, you divide by 1, this gives us 0.544. Once we have the moles, we move down and get the mole ratio, and the mole ratio is where we divide by the smallest. If you look at the number of moles of carbon and that of hydrogen, the number of moles of carbon are less, and therefore we are going to take 0.2182. We divide by 0.2182. Then we take 0.544. We divide by 0.2182. And this one will give us 1, while this one will give us 2.5. Having done that, having gotten the mole ratio, we can now convert this mole ratio into whole numbers. And if now you take 1, you multiply by 2, you also take 2.5, you multiply by 2, we are going to have 2, 2, 5. Once we have the mole ratio as a whole number, we can now get the empirical formula. The empirical formula is going to be equal to carbon. We have 2 moles of carbon, or 2 atoms of carbon, sorry. Then of course we have 5 atoms of hydrogen, so we write it as H5. So if you take the empirical formula, which is C2, if you take the empirical formula, which is C2 H5, we multiply by N. This one will be equal to what we call the molecular mass of the hydrocarbon, which has been given to be 58. So this one will be equated to 58. From there, we convert the empirical formula into the molecular mass, and in this case, carbon has a relative atomic mass of 12. Since there are 2, we take 12, we multiply by 2, and that gives us 24 plus. Hydrogen has a relative atomic mass of 1. We multiply by 5. This one is going to give us 5. Then multiplied by N, this one will be equal to 58. Once we are through with that, 24 plus 5 is 29, so 29 times n will give us 29n, and this gives us 58. And if you want to find the value of n, you divide by 29 on both sides, and our n is going to be equal to 2. Once we have the value of n, we can now get the molecular formula. So to get the molecular formula, we are going to take the empirical formula, which is C2H5. We multiply by the value of n, which is 2, and now the molecular formula is going to be equal to C2 times 2, which is C4. H, we have 5 times 2, which is 10, and that is the answer to this particular question. Thank you for watching and welcome to the channel.